In this video, we will be taking a look at a runner running on a track and the forces involved. More specifically, we will be taking a look at the beginning of my 200-meter dash at the SEC Championship. Here's the clip. It's quick, so stay on your toes. Both of us in this frame have our best running faces on. Take notes, this is the key to going fast. While running, there are 4 basic forces acting on me. For this free body diagram, we will start with gravity and normal force. Pretend that the circle in the center is me. Gravity is pushing down on me with an acceleration of 9.81 meters per second squared. With a little bit of math magic and force equals mass times acceleration, we can see that gravity is pushing down on me with a force of 645 newtons. I got my answer by multiplying my mass of 65.8 kilograms by the acceleration of gravity, which is 9.81 meters per second squared. Thank you, Guy from Sheehan, for letting me draw on you. The force that the ground exerts on me is normal force. It is equal to the force of gravity, meaning it is also 645 newtons, just upward instead of downward. These two forces cancel out completely, meaning I've been explaining to you the reasons why I'm not moving. Exciting, I know. Now we will move on to the interesting stuff. The reason I am so fast. At the start of the race, I have no velocity or acceleration. But fractions of moments after the gun goes off, I begin to accelerate. Numbers at this point are irrelevant. The force that causes me to move forward is called applied force. This is the result of me doing work, turning my stored chemical potential energy into kinetic energy. But let's not get sidetracked. Drag is the fourth and final force that is acting on me. This puny, tiny little arrow pointing to the left is drag, and it is caused by air friction, or air resistance. Surface friction really has no place here because I'm not sliding across the track. That would hurt. Let's take a closer look at where forces are coming from. The applied force is actually pointed slightly upward. This is because my legs push back and down on the track so that I get more power in my step. Being at an angle like this helps me to put more force into the ground to create more friction so that I can accelerate faster. The red arrow, which is the vertical portion from my applied force, is the pushback from the ground. It just gives me more friction to use to my advantage. The green arrow is the horizontal portion of the applied force that propels me forward. The friction gained from being at an angle allows me to put more force back into the track to move faster. Finally, there's the angle I'm leaning at. This is represented by the symbol theta. This is what determines what portion of the force is going up and to the side. This is done using sine, cosine, or tangent depending on what portions are given. Now that all that is going through your mind, let's play the video one more time. I'll slow it down for you this time. Thank you so much for watching. Please forget to like and subscribe because no one should ever have to bear witness to anything I've created.